Hi, this problem is to help you with calculating empirical formulas from percent composition. Either they give you the mass of each element present or they give you the percent composition. If it's the percent composition, there's one small extra step, but basically you take the percentages of each element and change them and basically pretend that you have 100 grams of it and you change it into you change it into grams. So if we have 65.02%, that becomes 65.02 grams of platinum. And we have 9.34 grams of nitrogen, 2.02 grams of hydrogen, and 23.63 grams of chlorine. Now, once we have that, our first step is to change them into moles, okay? We want to convert all of these into moles. And the way we go from grams into moles is by dividing by the molar mass of each element. So we use our periodic table. We set up a little grid, and we know that for every 1 mole of PT, platinum, according to our periodic table, the molar mass of PT is 195.08. So that's 195.08 equals. On my calculator, I go 65.02 divided by 195.08, and I get 0.3333. Since this has 4 significant figures, I want to have that go out to 4 sig figs as well. And that's moles of platinum. And I do the same thing with each of the other elements. To get from grams of nitrogen to moles of nitrogen, I know that for every 1 mole of nitrogen, there are 14.01 grams. So I go 9.34 divided by 14.01 equals, and I get 0.6667 moles of nitrogen. I do the same thing for hydrogen. That's 1 mole of H for every 1.01 grams of H. And I end up getting basically 1 mole of hydrogen. Technically, it should be 1.000 moles of hydrogen. And then for chlorine, for every 1 mole of chlorine, there are 35.45 grams of chlorine. And according to my calculator, 23.63 divided by 35.45, and I get 0.6666 moles of Cl. Now, the next step is I look at all of these values and I divide all of them by the smallest number. All right, and since the smallest number amongst all of these is right here, for the platinum, I divide everything by 0.3333, 0.3333, 0.3333, 0.3333. Now, when I divide, I want to round off to the nearest whole or half number. All right, and basically, we're trying to figure out what the ratio is, but we want them all to be whole numbers. So this, I divide by the same number, I'm going to get 1 platinum. Here, I divide 0.6 divided by 0.3, rounded off. I'm going to get 2, and that's going to be nitrogens. Here, 1 divided by 0.3, that comes out to be 3 hydrogens. And then 0.666 divided by 0.3333 equals 2 chlorines. Now, these numbers, all right, these numbers are going to become subscripts. Now, if they weren't whole numbers already, if you rounded off and it became, it was like 1.3 or 1.6 or 1.5, you then do the process again, simply dividing by the lowest number of these now until you end up with a whole number. Okay, so until you end up with all of them being whole numbers. But these end up being the subscripts. So I have PT1, N2, H3, Cl2. And that is the empirical formula for this compound. Now, this is how you do empirical formula problems for hydrates, all right? Compounds that are hydrates. Now, so we're looking at this, and first of all, we want to make sure we have the correct chemical formula for copper 2 sulfate. So real fast, I know that copper 2 is 2 plus, sulfate is SO4 2 minus. That's a 1-to-1 ratio, so that's going to be CuSO4. Now, we know, the one thing that we know is that it is 36.48% water. All right, and that's going to be a certain number of H2Os. And what we're trying to find is what is the empirical formula for a hydrate of this, and we want to find out how many waters there are. So the way we go about doing that is realizing, well, if we have 36.48% water, that means the rest of it is copper 2 sulfate. So we simply take 100 and minus 36.48, all right, 36.48, and we find out what is the percentage that is copper 2 sulfate, and we find that that's 63.52%. All right, now we keep these together as compounds. So we know that we have 36.48% water, 63.52% copper 2 sulfate. So we have CuSO4 and we have H2O. Now the CuSO4, we're going to change these, remember, into grams. So we know we have 63.52 grams of that. Okay. And for the water, we have 36.48 grams. Now we need to then convert them into moles, just like before. Now we need to have the molar mass of CuSO4. So off to the side here, actually I'm going to go over here, I know I have one copper at 63.55. I have a sulfur, which is 32.07. And I have 4 oxygens, each one is 16, so 4 of them are 64. I add it all up, 32.07 and 63.55. I get a molar mass of 159.62. So I know that 1 mole of CuSO4 is equal to 159.62 grams. So I take 63.52 divided by 159.62, and I see that that is 0.3979 moles of CuSO4. I do the same thing for water. Water's molar mass is 18.02 grams for every 1 mole. All right, and that's CuSO4, that's H2O. So I get 36.48 divided by 18.02, and I get 2.024, excuse me. All right, and that's moles of CuSO4. Now I do the same thing that I did before, and I divide by the number of, the number of moles that is the lowest. So I'm going to divide each one by 0.3979. 0.3979. That's obviously going to be 1. But on my calculator, when I take 2.024 divided by 0.3979, I get 5.08785, so forth and so on. And I round that off to the nearest whole number. All right, so you can see how I have that. It's going to round off to the nearest whole number, which will be 5. So for every 1 CuSO4, I have 5 H2Os. And that equates out to CuSO4 dot 5 H2O. And that is the empirical formula for a hydrate. I hope that was useful.